Good evening, my 11th standard warriors. Welcome aboard to the next session of rotational motion and rigid body mechanics. Today we're going to see two very special topics. The first one is finding the instantaneous axis of pure rotation, and then we'll also see that rotating bodies also have angular momentum, and we are going to see how to calculate each one of that. All of this with me, your favorite captain Shreyas, going live on JEE Enthuse, the dedicated English medium channel for all the engineering aspirants. Hi Suchi, nice to see you guys were there just before the lecture started. Hi Akhil, Ishpreet, Dakshin, Aishwarya, nice to see you back from the Pathfinder then to Nurture. Hi Roshni, hi Akhil, hi Abhinav, good to see you, regular student. Finally Abhinav, nice to see. Suchi is super excited. Yes, me too. And I had back-to-back sessions, but let me tell you, my excitement is not down even a little bit. Alright, hi Vashni, hi spread positivity, and I hope you really spread positivity. Wow, Harita, good, you did it well. Proud of you, bacha. Keep doing well and keep rocking like this till the 12th standard. Don't lose it at any given point. We are always there with you. Hi Darshan, good evening. So those of you who do not know me, I am Shreyas. I am the physics master teacher. And I have been training for almost like a decade now. I did my engineering from NIT Nagpur, I did my research from IIT Bombay, and then I entered into a software company, and then I decided to start teaching. And then when I saw students scoring really well, I was like, okay, I should be really serious about this profession. And then there's no turning back, and here I am. Lots of my students have not just cleared JEE, but they have also got really good, amazing ranks. Many of them 2-digit All India ranks. They have made me super duper proud, and I'm really hoping you too will make me proud one day. And if you're 11th, hopefully in JEE 2023, I'm going to see all your posters everywhere around the city and everywhere all over the internet. So if you want to know more about me, you can definitely follow me on my Instagram handle. And let me tell you, just in case if you have any backlogs, or if you feel like you need some help, or if you're lagging behind, or if you have some you need some additional practice questions, or you do not have the right book, then don't worry, we have all the things covered in one platform. We will give you assignments, we will give you a test series to see where you are, we will have classes to cover up your backlogs, we will have mentors. If you have doubts, you can ask your doubts to our academic experts. We can give you a plan, and yes, we'll give you the lectures in English. All of this in our pro subscription. And guess what? There is EdFest going on, and you can take full advantage of it by using my coupon code SHHPRO, where you get 50% flat off, and then you can study right from your home. So do not miss this chance. Go ahead, check out the course links which are there in the description box below. Let's get going. Hi Gokulnath, hi Surya. Oh yes, so you Raj, I have taken your name. Alright. Hi Ayappan, Sarguna, welcome. I'm so glad Dakshin you got boosted because of my micro courses, and that's what I always recommend my students. Go to VPro, check out my micro courses and so many other micro courses from so many other teachers too. Chandan also was watching my HC Verma micro courses. Just in case some of you do not know, I already have my HC Verma micro course, derivation micro course, then problem solving micro course, Erodo problems micro course. It's all there in VPro. Take full benefit of it. Don't leave it. Try it for 15 days, and in 15 days, fatafat watch it if you want to. Okay, hi Sandeep, hi Aisha, good to see you back, all of you. Hi Sundar, nice to see you. Yes, so can you follow my lectures and DC Pandey for NEET Physics? Yes, Ram Kailash, why not? You can definitely do that. In the exam, Harita, there were many questions which came, which we did in the class, and it came in the exam, and every year it happens. At least 1 or 2 questions out of the 30 questions come in the examination. In fact, if you look at pattern wise, there are 5 to 10 questions which directly get repeated. Maybe the values get changed, the situation changes a little bit, but same type of pattern questions come in the JEE Mains. I have seen this so many times again and again. Now, let's talk about first rotational axis. If I ask you what's the difference between translation, rotation and translation plus rotation, immediately you will start picturizing different examples and scenarios in your mind. Look at this body. You can see that this body is rotating and it is moving. What exactly does it mean by rotation and translation? And is it possible to find the axis of rotation for a given body by getting some data points, by getting some values? The answer is yes, and we are going to try to figure that out. The first example that I want you to see of is pure rotation. Look at this Pandu. This is our Pandu. He is our observer. So what is this Pandu doing? This Pandu is our observer, and what is he observing? He is observing this fan which is kept inside this truck, and right now the truck is at rest. Okay, the truck is at rest. The fan is on. If the fan is on, obviously the blades will rotate. Isn't that right? The blades will rotate. It will rotate about this axis. So this is basically the axis about which the blades rotate, and this axis is also at rest for this observer because the truck is at rest, the fan is at rest. So this axis is also at rest. When you find that for a body which is moving or whatever, it's in motion, and you find that there is one point on the body which is at rest and all other points are rotating around it, then that axis is called as the axis of, so if there is an axis at rest, that is called as axis of pure rotation. Very, very important. It's just rotating. There is no translation. This is the axis of pure rotation. All the other points go in circles around that particular axis. Is that clear, my warriors? Rudresh, I'm very fine. Glad to know that, Aisha. So glad. I'm so happy you guys are taking full advantage of my micro courses. Now I think I should do even more. I'll do something more. Don't worry, guys. Yep. Thank you, and always welcome spread positivity. Yes, and do not forget to smash the like and subscribe button and share it with your friends, because when you like and subscribe, it also gives us that positivity to spread the channel and spread the video across the country and to many other students like you who would get lots and lots of inspiration and learnings from this channel. Okay, now this is the first scenario where it is purely rotating. Look at the second scenario. Now the truck is translating. It is moving. This is our same observer. Pandu is our observer. What he will see, the truck is moving, hence the center of the fan, which is the axis of the fan, is also in motion. Now, if you look at the particles, think about it. For this observer, Pandu, which is outside, please understand the motion of the particles on that fan is not circular. Remember, the fan itself is moving, so the actual motion of any point is actually something like this, because it is moving. Think about it. It's moving and it is rotating, so each particle is going in some weird way. Is that understood? Now, that should give you an idea that, wait a minute, now I don't think each particle, is rotating purely about this point. Definitely not. And if this is off, let's say the fan is off, if the fan is off, then all the particles will just go straight. There will be no rotation. All the particles will just be in the same motion as that of the truck. When it is not rotating, every particle moves parallel to the other particle, then it is pure translation. So what is pure translation? Pure translation means all particles motion is parallel to each other. It's parallel to each other. So there is no change in the orientation. So if I take this pen and move it like this, it's purely translating. If I take this pen and make it move like this, it's rotating and translating. If I just do it like this, then it is just rotating. So I hope you get the difference. So translation means it should not turn even a little bit. It should just go as it is. If it goes like this, it should go like this. If it goes like this, it should go like this, but it should never change the orientation. Is that clear, my warriors? Hi Lakshmi. Hi Lakshmi. Definitely Salva, Anikiltan, definitely I'll make. So translation means, that's what it is, Suji Mama. Read the definition. All particles motion is parallel to each other. So if you take any body like this particle goes like this, so this particle also goes like this, even this particle goes like this. They are parallel. You can see at any given point of time they are parallel to each other. That's the meaning of pure translation. Great. Now when I said combined motion, that is rotation plus translation, then the motion is very weird. Like you can see over here, the blades of the fan are rotating, and plus it is in motion. You will see each particle will go in different weird paths, and that becomes a problem. Now let me tell you, there is a very easy way for solving problems of rotation plus translation. Yes, ball rolling down the incline. Hi my minion, nice to see you on this channel back. Yes, ball rolling down the incline is a good example of translation plus rotation. A table fan which is on and it is swinging, that is also a good example of translation and rotation. You rotating your hand is pure rotation, but if you start moving, it's rotation plus translation. Understand that. So if you start moving, then that is rotation plus translation. Now guess what? Whenever you have combined translation plus rotation, okay, whenever you have combined translation plus rotation, you can do a magical thing, and that magical thing is you can convert it into just pure rotation. Yes, you heard that right. I'll repeat. Whenever you have a combined motion which is rotation and translation, you can figure out one axis about which it is just rotating. It's just rotating. It's crazy. Santwana is asking, can you show a figure of rectangular lambda? Santwana, today we are not discussing moment of inertia, bacha. We are discussing something else. But any doubt that you have, you can definitely post it in the comments after the video ends, and definitely I'll get back to you. Yeah, or ping me on Instagram, Shreyas_Vedantu. Maybe I'll help you. Okay? Yes. Now how do I do that? There is a logic for it. I have this body which is translating and rotating. How do I find an axis, or how do I convert it into a problem of pure rotation? We'll see that. But let me define this instantaneous axis of rotation first. This is nothing but that axis about which any translating plus rotating body appears to do only rotation, nothing else. So it's that axis about which the body appears to do only rotation and nothing else. That is called as, instantaneous axis of pure rotation. And there is a very easy way to figure that out. Just imagine, by definition, it appears to do only rotation. So imagine this is our body. Just imagine this is our body. If suppose this is the instantaneous axis of rotation, instantaneous axis of pure rotation, then all the particles in that body will go around circles around that point. So this point over here will go in a circle like this. This point over here will go in a circle like this. This point over here will go in a circle like this. Isn't that true? All the points will go in circles around that particular point. And the best part is, any point over here will have a velocity, let me just put it in a different color, will have a velocity like this, and it will also depend on how far you are from the axis. Let's say this is V1. This point, or maybe this point over here will have, this point over here will have a velocity like this, let's say V2. Maybe this point over here will have a velocity V3, and so on and so forth. Guess what? These velocities are always perpendicular to the line joining that axis and that point. So remember, in a circular motion, the velocity is always tangential. So these velocities are always perpendicular to the line joining, or the distance between the axis and that point. Not just that, these velocities will be omega into distance. V1 will be omega into distance. In general, the velocity is not only perpendicular to the distance, but also the velocity is equal to omega multiplied by that distance. Very, very important. Omega r. Isn't that clear? Yep, that's so cool. So cool. Yes, that's instantaneous axis of rotation. So this instantaneous axis of rotation makes that body behave as if all the particles are going in circles, and each velocity is not just perpendicular to the distance but also proportional to that, and you will also have angular velocity. Can they be same in certain cases? Yes. Imagine two particles on the same circle. So if there are two particles on the same circle, obviously they will have the same speeds. They will obviously have the same speeds if they are on the same circle. You can see that because r will be same, omega is same. This is very important. Omega, which is angular velocity, this is same for all particles. This is same for all the particles because each particle will cover the same angle in the same time. So the angular velocity is same. I hope that makes sense. Now comes the next question. I now know how instantaneous axis of rotation looks like. I know what particles do once I know the instantaneous axis of rotation. But how exactly do you find it? That's the challenge. How exactly do you find it? Varshini, I just said omega is same for all the particles. Look at your fan. No matter which point you take on the fan blade, okay, let's say this is your fan, okay, maybe this is your fan like this. If you take this point, it covers this angle. This point also covers the same angle in the same time, okay. Remember, the angles covered are the same, only the distances are different. That's why the velocities depend on r. R is different, V is different, but omega is same for all the particles. That's all I said, okay. So I hope that makes sense. Now, my point is, how do you find this instantaneous axis of rotation? Let's try to figure that out. But before that, all the important pointers that you need to know. First, go through this. The combined translation and rotational motion of any body can be converted into pure rotation. We are going to figure that out. That's what I told you. Any translating and rotating body can be converted, can be reduced into just rotation, and that point about which it just rotates is called as instantaneous axis of rotation. So that point about which it just rotates is called as instantaneous axis of rotation, and the rigid body performs pure rotational about this axis with same angular velocity at that moment. Remember, I just told you. No sine wave, this is very different from that. Yeah, these are new series for all of you, so you should definitely watch the new series, which is the nurture series sine wave. So all the points have same omega but different velocities because V is omega r, omega is same. How do you find this? Very interesting technique. I'll tell you what you should do. Just imagine I throw some body. I throw some bottle, I throw some compass, I throw some remote, I throw some duster, I throw some pen. Doesn't matter. It's going like this. It's rotating and translating. And at some instant, there is some body over here. It's rotating and translating. So this is rotating and translating body. And I want to find out what is the instantaneous axis of pure rotation. How do I do that? So I go reverse. How will that axis be? That axis will be such that it will be at rest and all particles will go around it. Okay. Guys, tell me, can axis of pure rotation, Varshini, you can go back a little bit, even in the live video, take that slider below. If you're watching on mobile, laptop, doesn't matter, just take that slider, go a little bit behind and come back. You can go back and come back. Okay, that's an option available. Now, answer this question. Is it necessary that axis of rotation should always lie inside the body? Is it possible axis can lie outside the body as well? Come on, think about it. I am waiting for all your answers. Is axis of pure rotation necessarily inside the body? Can it lie outside the body as well? Think. Then the axis, we change it, is called axis of pure rotation. Yes. that axis which you find is axis of pure rotation. Abhinav saying yes, Roshni saying yes. Yes, it can be outside. Just imagine if you have some body and this is instantaneous axis of rotation, then it is possible this point is going in a circle like this. This point is going in a circle like this. This point is going in a circle like this. So this body is rotating and translating. So you can see that. So axis can lie even outside. No problem in that. Now, how do I find it? All you need to give me is 2 points velocities. If you just give me, what am I demanding? Give me, what do you need to give me? Give me 2 points velocities. What I will tell? I will tell basically the instantaneous axis of rotation. So you just give me 2 points velocity, I will tell you where the axis of rotation is. It's very easy. How? Just imagine this point. I'll tell you the velocity is like this. Let's say I call it V1. Then I tell you there's another point here and the velocity is like this, V2. I know velocities are always perpendicular to the distance from the axis to that point. So I know for sure if I draw a perpendicular to this velocity, the axis of rotation may lie somewhere on this line. I don't know where, but it will definitely lie on this line. I also know if I draw a perpendicular to this velocity, the axis of rotation will lie somewhere on the green line. Now wherever they intersect is the sure shot location where the axis of pure rotation is. Isn't that clear? Isn't that clear? It's just like center of mass. Yes, Roshni, it can lie outside and inside. Yep. Hi Varubar, good evening. Alright. Yes, in a hollow circular disc it lies outside, correct. So this is the locus of all the points where the axis can lie. This is also the locus wherever they intersect is actually the instantaneous axis of pure rotation. That's it. It's done. Ho gaya. Problem solved. And let's say this is R1 and let's say this is R2. I think I can just do this simple logic. Let's say I can also find omega. So it is rotating. This will be omega. So V1 will be omega R1. V2 will be omega R2. I can find omega by this. And if I ask you some other points velocity, that's also easy. Let's say I ask you to find the velocity of, let's say, this point over here. Nothing. Just draw a line from here to this point and just drop a perpendicular. That's it. This velocity will be omega into that particular r. Simple. Done, done, done. So Varshini, there is no formula for everything. Remember, there is a procedure. This is not a formula, this is a procedure. Keep this in mind. And JEE is never about formulas. Just about formulas. It's all about the procedure. It's about the thinking. It's about the steps you follow. So till 10th standard, everything used to be like, sir, what's the formula for volume of a sphere? Okay, substitute volume, get the answer. But here there is a procedure, there is a step. You have to think and you have to improvise based on what is asked. So understand the concept behind axis of pure rotation. So what's the concept again? If I give you any goddamn body and I tell you where is the axis of rotation, what you should ask? So tell me 2 points velocity. Let's say I give you this point, velocity here, and I tell you there's one more point, it has a velocity here. This is V1, this is V2. What are you going to do? Just draw perpendicular and perpendicular. See where they intersect? That's the instantaneous axis of rotation. And that will give me omega, which is V1 by R1 or V2 by R2. One and the same thing. Is that clear? Varuban, maybe it might be useful for CBSE, but CBSE is more theoretical than JEE, and JEE has more of application and concepts and problem solving and lot of interesting questions. Alright, I hope this is clear. So no need of FVD. No need of FVD. Okay, so that's the way. Oh, by the way, you will get all the PDF on our Telegram channel. The Telegram channel link is there in the description box below. Do not forget to join the Telegram group. Let's solve some problems. But before that, I have some important announcement for all of you, and that is Vedantu's mega scholarship admission test. What is this scholarship admission test? See, it is going to be on Wednesday from 8 p.m. It's applicable for all the grades right from 4th to the dropper batch. This is an online test. You don't have to go anywhere. You can give it from home. and you will get scholarship for your entry into Vedantu. And there is a minimum scholarship of 15%, and if you do really well, you get 100% scholarship. There is a pool of 100 crore rupees we have assigned, and from this pool you will get the scholarship. There are also amazing prizes, and the registration for this is free. What you need to do, oh by the way, some of the prizes: rank 1 will get an Apple iPad, my god, 9th generation. Rank 2 to 5 will get a Kindle. 6 to 10 will get both AirPods. 11 to 50 will get Vedantu bags. It's crazy. What's the syllabus for you guys, 11th standard kids? There will be 3 sections: physics, chemistry, maths. These are the patterns. Basically, you will have 12 questions, and maths will have 11 questions, totally 35 questions. They will be all objective. Only one answer will be correct. 4 marks for correct answer, and incorrect will be -1 marks. So negative marking is there, and you will have 90 minutes to attempt the paper. And remember, most of the questions, will be from your class 11 syllabus, and some of them will be also, based on your 10th standard syllabus as well. So go ahead, register to VMSAT using this link, which is vmsat.vedantu.com, and enter all your details. It's free of cost, and you will get assured scholarship, minimum 15%, maximum 100%. Just choose your grade, put your name, choose your target examination. It's very easy, it's self-explanatory, and you will be able to register for the exam. Okay, so do not forget to register for this examination. All right. Okay, my theory, is it enough? See, Jagdeep, no teacher's theory is ever enough. Okay, no teacher, be it YouTube, be it Vedantu Pro, be it any offline coaching, you should always use books. Always. This should be a habit. Okay, if any teacher tells you just attend my lectures and that's it, you will be a genius. No, that's never going to happen. Okay, so you have to refer books. Books give you some different perspective. You will also able to understand. You can mark some important points. You will also get a different way of solving the problem, and you'll also get some additional pointers. So always refer books every time, no matter whose lecture you attend, no matter whether it is 11th standard or whether it is college. Always use books. Okay, Jagdeep? Cool. So let's start solving some questions. Let's see how many you can find this answer. Find the instantaneous axis of rotation for this sliding rod. Okay, come on, my warriors. Figure this out. Find the instantaneous axis of a rotation for this particular sliding rod. Okay, this rod is sliding. It's going like this. It'll be like, so it's so difficult. I'll give you a hint. The rod's length is L. The angle is theta. At this instant, where is that axis? What do you need? You just need 2 points velocities. Do you know 2 points velocities? I think you know. Think carefully and just let me know where the coordinates are. Jagdeep, which book to use for theory? Part I'm finding H.C. Verma difficult. For theory part, suggest some good book. So Jagdeep, if you are finding H.C. Verma itself difficult, then I would say use Halliday and Resnick. Okay, you can use that, but that's even bigger book, and there are a lot of topics which are not there in JEE. So you need to use that book very wisely. So that's why we usually recommend H.C. Verma. So if you like Resnick and Halliday, please use that. Okay, if you are finding H.C. Verma difficult. So that's what I would suggest. Okay, so instantaneous axis of pure rotation for this sliding rod can be found very easily. I'll tell you how. You just need 2 points velocities. This rod is sliding like this. I know this end is coming down. So hence this point has a velocity here. This is velocity 1. This end, bottom one, is going this way. So for sure this end has a velocity like this. Let's say I call it V2. What do we do next? Drop perpendiculars. So let us just drop a perpendicular over here, and let us also drop a perpendicular over here and see where they intersect. Perfectly intersecting over here. So this is instantaneous axis of rotation. Done, done, done. So if I take this as the origin, I think I'll get the answer in terms of coordinates in case we want it. So this is the origin, and let's say this is my x-axis, and let's say this is my y-axis. I think I know what these lengths are. If this is theta, this is L. This height over here will be L cos theta. Sorry, my bad. This will be L sin theta, and this base will be L cos theta. So this point over here, what will be the coordinates? The x coordinate of this point will be L cos theta, and the y coordinate will be nothing but L sin theta. So those are the coordinates of the instantaneous axis of rotation. Okay, so I think Jagdeep, now I answered your question, and Akhil too has understood this. Clear? Isn't it easy? So easy question. Okay, it just looks difficult. Let's solve another question. Wow. Oh, I don't know why homework has come. This was not homework, guys. This is supposed to be solved here. Okay, don't get excited. Oh, we have to solve it at home. Okay, so find instantaneous axis of rotation for this body shown. I think two things are missing. Those are the velocities. Let me just mark it. This was supposed to be 2v and this was supposed to be v. Okay, for this particular body over here, find axis, find angular speed, and also find the speed at that point b. Okay, let's do this. Now is a big problem, and many of you will realize this. As soon as I draw perpendicular, I know velocity of this point and this point, so I should just draw perpendicular. Let's just draw perpendicular. So this is a perpendicular, it goes like this, goes like this, goes like this. Okay, so I've drawn the perpendicular for this velocity 2v. Let me draw the perpendicular for v. Hold on, that perpendicular is the same. Don't you see that? This is the same perpendicular. So where will they intersect? It's crazy. It's not intersecting. Kartika, all my micro courses are still available now, bacha. Yes, it is available. Okay, you can definitely join and take it up. So where are they intersecting? They are not intersecting. So then you'll be like, so there is no instantaneous axis of rotation? No. The thing is, you have to use your brains. Yep, think carefully. Velocity is proportional to the distance from the axis of rotation. Do you see that whenever a body rotates about an axis of rotation, the velocities slowly increase as you increase the distance? So it's proportional to the distance. So there is one point which has no velocity. As you go away, the velocity keeps increasing. And I think I can see that right over here. This point has very large velocity. As you go down, velocity is less. So I think if I go more down, there will be a point which has no velocity. So somewhere here, there will be a point whose velocity will be 0, and that will be the instantaneous axis of rotation. It will be somewhere down. Is that clear, my warriors? Exactly. Now, yep, it will be collinear. Now the question is, how far is that point? That is not difficult. Think carefully. If you visualize a triangle over here, similar triangles, I'll tell you how. This is 2v, this is v, and just imagine a triangle. Somewhere it is 0. This distance from A to C, I'll just mark the points. Where is that? Yep, I'll just mark the points. This is A, this is C, this is instantaneous axis of rotation where velocity is 0. How much is this distance? This distance, AC, is diameter, which is nothing but 2r. So how much should this be? Think carefully and answer. If AC is 2r, how much should this distance C to this point should be? Isn't it very easy? Isn't it very easy? Come on, think. Yes, it should be exactly the diameters. This should be also 2r. Similarity of triangles. This triangle is similar to this triangle. So if this side and this sides all are in the ratio, if this is 1, this is 2. So this is 4r, this is 2r, 2r. I mean, it's very obvious, isn't it? It's very, very obvious. So from 2v to v, it came down in 2r. So from v to further 0, it will come down in 2r. Same distance. Isn't it simple? Okay, very good. So this distance, I've just found it out to be exactly equal to 2r. So my first problem is done. Let's solve the C part first, and then let's go to the B part. The next part is, what's the angular speed? Well, that's also easy. The angular speed, okay, about that axis of rotation, omega will be any velocity divided by that distance, v by r. So I can write it as v by this distance, which is 2r. I can also write it as 2v, but then this whole distance will be 2r plus 2r, which is 4r, which is one and the same thing, 1 by 2r again, so v by 2r. Okay, so I think I have found out omega also, the angular speed of rotation. It's any point's velocity by the distance, as simple as that. Isn't it clear? Everybody clear till this point? Shall we go ahead? Okay, last question. What is the speed of this point B? What is the speed of this point B? So how do you find the speed of any point? Start by joining a line from that point to the axis of pure rotation. The velocity is always perpendicular to the distance. So this is VB and this is perpendicular. In order to find VB, I think I will require this line length RB. What is this line length? That I can find out via Pythagoras. So I need geometry over here. Do you see this big triangle? This is R, this is R, this is 2R. So this whole thing is 3R. Can you see that? R plus 2R is 3R. This is a right angle triangle. So I think I can find out RB. So RB will be root of, it will be root of 3R square plus R square. So R will come outside. 3 square is 9 plus 1. So it will be R root 10. So what is the velocity at any point? It is omega into that distance. I think I know omega. It is V by 2R. I think I know R as well. It is R root 10. So R goes. So V root 10 divided by 2 is that velocity. I have solved that question as well. If you go step by step, if you think logically, if you do not get scared, then you will get to the end of the solution. And that's what we have done. So beautiful question. This can be like an advanced type of questions because multiple things were asked, but it's not so difficult as well. Rajat, most likely it should be in February. Okay. So that completes axis of pure rotation. And now let's go to angular momentum. Everybody remembers momentum? Yes, we have studied the chapter of momentum and collisions. So what is momentum? Momentum is the effect of mass and velocity, how much impact a moving body creates, okay, when it hits and it gets transferred to the next body. Same way, a rotating body also has angular momentum. Just think about it. Okay, let's just visualize this. Now let's say we have a Pandu over here and this is his hand, okay, and he's holding something over here. He's holding something over here. The other hand is in his pocket. This is his Pandu and he moves like this. He moves like this, okay. There is something heavy on his hand. And let's just visualize this from the top. This is the Pandu, this is his hand, and this is the mass. This is our Pandu. And Pandu can rotate his hand like this. This is that mass. Now, just visualize if there was some body, okay, in front of him. Maybe he's slapping some other guy. Oops. This is some other guy, okay, who is there in front of him, okay, and Pandu is slapping or hitting that other guy with that heavy mass, okay, he's hitting that. If this mass hits him this way, okay, if this mass hits him exactly like this, then this body will start rotating. Then this body will start rotating, isn't it? If that guy is standing over here, imagine he gets hit like this, he will start rotating, assuming that he can spin about his axis. Just visualize that. So there is some kind of angular momentum involved over here. I don't know whether you see that. Angle wise, there was a momentum which was imparted to the other guy. So any particle which moves has angular momentum, and that's what we are trying to calculate. It's crazy. And let's see what that angular momentum is. So imagine that there is a mass m, and let's say it is moving with certain velocity v, and here is the point about which you will calculate the angular momentum. This is very important. In normal momentum, you never had a point about which you calculate the angular momentum, but in rotational motion, you always need to calculate things about an axis, about a point. Take the example of mass. You never calculate mass about a point, but inertia, moment of inertia, you always calculate about an axis. Torque is the equivalent of force. You always calculate torque about an axis. Force, you never had to worry. It's a force, that's it. But torque, you're twisting it about which axis. Same way, momentum also is calculated about an axis. You always need that. Is that clear, my warriors? Oh my god, Payal has physics exam tomorrow. So Payal, all the best. But let me tell you, I will help you for the next physics exam if you watch all my lectures properly. But just one night before, it's a little bit difficult. Okay, so you always calculate it about a point. So point about which angular momentum has to be calculated. Okay, so this is what it is, and this is the mass, this is moving. So first thing that you need is you join that point to this mass. So you need that position vector r. So what is this r? R is nothing but, okay, R is nothing but position vector of that mass with respect to that point O. It's the position vector, it is not the radius. I have been telling this to you even in torque. R cross F, that R is not radius. It's always the position of that point of application of force, or the mass in this case. Now, what you need to do? The angular momentum. Oh, I forgot to tell you the symbol of angular momentum. Angular momentum ka symbol is capital L. Okay, this L in that angular momentum has come over here. So the angular momentum symbol is L. This is very important. And since it's a vector, you put a bar. We'll come to the directions in a bit, but for now, just let's take it for granted it's a vector. Now, this velocity, just like in force, has two components. So let me show you both the components of this velocity, and one component is here, the other component is here. This angle is theta, this is V cos theta, this is V sin theta. I want you to think, which component do you think will create an angular impact? I'll give you another way of looking at it in case you're not able to think clearly. If a particle is going like that, okay, if it's going with V cos theta, will it create an angular impact, or will a particle going with V sin theta create an angular impact about this axis O? So imagine this is the axis. A particle with V sin theta will create angular impact, or will a particle with V cos theta create an angular impact? Think about it. Come on, my warriors. Think about it. Vashni, you are not satisfied. I'm not sure why you are not satisfied. Probably you should write a message after the lecture ends, or probably post a message on my Instagram. I'll try to reply. Yes, V sin theta, not V cos. See, look at this. Imagine this is the pen. Okay, and if I apply V cos theta, it just translates. It does not rotate. So V cos theta. But V sin theta, it rotates. Correct? So V sin theta is responsible for angular momentum. Yes, so V sin theta causes angular momentum. Very, very important. What is this? This is useless, waste fellow. Yeah, nalayak fellow, waste fellow, chappal. Okay, it's not useful for angular momentum. It's just there. Yeah, we don't care about it. Now, this angular momentum is dependent on three things: mass, V sin theta, because V cos theta is useless, and the distance. More the distance, more the angular momentum. If you're going in a small circle, less angular momentum. Large circle, then it has large angular momentum. Just like imagine, if you have to slap somebody, I give you a task, slap somebody. Will you slap like this, or will you slap like this? Come on, show it in the comment section. Dr. Alka Yadav already has raised the hand. Very good. Alka Yadav, are you slapping someone like this? Okay. So how are you going to slap? Come on everyone. Are you going to slap like this or are you going to slap like that? How are you going to slap? Obviously you're going to extend your hand and you're going to punch like this. So more the R, more the angular wise momentum. Isn't that clear, my warriors? Yes. So it's also dependent on this distance. And that's why the formula for angular momentum comes out to be mRv sine theta. This is the formula for angular momentum. Great. Correcto. Varshini is going to punch like that. Very good. And you can see R is a vector, V is a vector, sine theta, immediately cross rule. We're going to come to that. But let me tell you, you can also write angular momentum as m r v perpendicular. This also works. That means the perpendicular component. This is the perpendicular component. This v sine theta. You can also write it like that. You can also write it m. You combine r and sine theta. So r's sine theta, na, it will become r perpendicular into v. So this r perpendicular is basically r sine theta. This also works. Instead of splitting velocity, you can also split r. So that r which is perpendicular to the velocity, meaning, look at this. This was your r, this was your velocity. So drop this perpendicular, this is your r perpendicular. This also gives you angular momentum. All these are the same things, but you have to remember any one of them. But remember the other two also are there. So this is the formula for angular momentum. And you can see clearly the units are kg, meter, meter per second. So kg, meter into meter, meter square per second. That's the unit of angular momentum. But in vector form, this formula will change. You have to just add few symbols. And what is the symbol that you'll add? The symbol that you'll add is angular momentum vector is m r cross product with velocity. R cross v. So this is the actual vector formula of angular momentum. Now let's see the direction. See, velocity is that way. Position vector is here. If you have to do cross product, r cross v, r is here, velocity is here, r cross v. You cannot do r cross v like that, obviously. R cross v. See, where is your thumb? It's coming towards you. So this, that means towards you, that's the direction of angular momentum. Yep, I hope this is clear. The angular momentum vector is coming towards you. Very, very important. R cross V. So vector product is very important. Yes, Kumaran, you can definitely watch Bacha. Definitely. Syllabus is same, but some of the questions could be a little bit more complex, but that's okay. It will help you anyways. And I can see you posted my picture. Is that me in your display picture? Thank you so much. Thank you so much. Okay, so going back, let's revise again. Angular momentum vector quantity is the effect of mass moving at certain distance which impacts and creates angular velocities, and it is r cross m, or mass is there in the momentum, so m r cross v or r cross p, one and the same thing. You can see that in this diagram also. This is the position vector, this is the momentum vector. R cross p gives you the angular momentum. You can see that vector. It's always the cross product. Okay, m r cross v, v and momentum, one and the same thing, same direction, just difference of mass. Okay, let's do some questions so that you get a hang of it. Okay, come on my warriors, this is your first question. Let's see how many of you can do this. Dakshin, it's not my birthday, bacha. My birthday is over, long time. Yeah, you have to wait more half a year. A mass is whirled in a circular path with angular momentum L. If the length of the string and velocity both are reduced to half, what is the new angular momentum? Let's see how many of you can get this. Come on, my warriors. Hey, it's not my birthday. Oh my god, it's not my birthday. Oops. Wrong info. Somebody gave you wrong info. Yeah, thank you. Advance happy birthday or belated happy birthday, because my birthday got over 6 months, 4 months back. So you should wish me both. Advance maybe and belated maybe. Hai na, Dakshin? Okay, come on. Let's see how many of you can get this. Hello Sumeda, join in. Even if you guys have missed certain parts, and if you know this topic a little bit, start solving the questions, and if you missed something, go back, watch the replay and come back to the current point. Yeah, Tattva is necessary, but you need to solve more than Tattva, whatever books are recommended to all of you. Thank you Roshni, thank you for advance happy birthday, and advance happy birthday to all the warriors out here on the channel, and belated wishes because I could not wish you and whatever birthdays I missed this year. Alright, chalo, let's see how to solve this question. Coming up on your screen, angular velocity and the what is reduced? The length of the string, both are reduced to half. So imagine this is the string, this is the mass, it's going like this, rotating like this about this point, okay, and this is the velocity, this is the mass, this is the length. Obviously it will have some angular momentum. The angular momentum will be mass into r into v into sine theta. Remember, this is r, this is velocity, they are perpendicular. So this theta is technically 90 degrees, correct? And what is sine 90? It's 1. So it is basically m, r is L into v. But wait a minute, velocity I know is omega into r or L. V is omega r, this is omega. So I can just write this as omega into L. So it will become L square. So m omega L square. That's angular momentum. Why did I do that? Because length is given and angular velocity is given. What have been done? Both are reduced to half. That means omega, you make it half of the previous value, and length also is made half of the previous value. So if length is half, the square of the length will be half squared. Isn't that right? And what is half into half squared? Half into half squared is nothing but 1/8. So the left hand side should get multiplied by 1/8 to preserve the equality. So if this reduces by 2 times, this reduces by 1/4, this will reduce by 1/8. So the answer will be capital L by 8. How many of you got this? Very good, Vashni, Suchi, Dakshin, Roshni. Excellente. Excellente, my warriors. Proud of you. Proud of you. Proud of you. Very good. Very good, Harita. Very good. Chalo, let's go on to the next question. Okay. So what do we have over here? Here we have a particle of certain mass. It's at certain distance, certain velocity. Question is, find angular momentum about some random point, not the origin. So what it means is, see, you have a particle, it has some velocity, okay, and it has some coordinates, okay, it has some coordinates. What are the coordinates? 3 and 2, okay, 3 and 2, and you have to find the angular momentum about some random point O. This is your mass. So first thing that you should visualize is the position vector from this point O. And this point O itself has, oops, sorry, my warriors, this is not 3, 2. Yeah. So the particle is at a point 4, 1, and the particle angular momentum has to be found about the point 3, 2. So the first thing that you should do is figure out what this position vector is. I think that's very easy. That's very easy. You have done this so many times. 4 units x coordinate, 3 units x coordinate. So I know what is the x component already. So that position vector, think na logically, that is 4 units in x. This point O is 3 units in x. So what is the x component? Obviously it is 1, right? So it will be 1 I cap. As simple as that. If you did not understand it, let me put it over here. 4 minus 3 I cap. I hope that makes sense. Same way, the y component will be 1 minus 2. So plus 1 minus 2 j cap. So what will you get? I cap minus j cap meters. So that's r vector. That's the first thing. Yep. That's what you need to do. Yeah, Vaishnavi, I think you need to little bit roll back. Yeah. Even in the live class, you can go at 2x speed and come over here. But if you want, you can continue in the live session. Live sessions are always fun. Okay. Now the next thing that you need to do is use the definition. Remember angular momentum definition? Angular momentum definition was m R cross V. So let's do R cross V first. How do you do R cross V? Remember, whenever you have to do cross product, let's just do this. I don't think I need to use determinants because they're just two terms. So let's just try to do R cross V and see what do we get. R cross V will be nothing but this thing, which is I cap minus j cap cross velocity. Velocity is 3I cap plus 6j cap. I into I, 0. Okay, I will not go with I. Remember, I cap will get multiplied with j cap and j cap will get multiplied with I cap. Okay, very, very important. Okay, because I cross I is 0, j cross j is also 0. So I cap into j cap, which is k cap. So it will become 6k cap. J cap into I cap is minus k cap, but minus into minus will become plus. J cross I is minus k. Keep this in mind. So minus into minus will become plus. So plus 3 k cap again. So this will give me nothing but 9 k cap. Great. I found R cross V. So how much is the mass? Mass is 2. And into 2 into how much? 9 k cap, which is nothing but 18 k cap. So where is 18? 18 is there as option C. Done, done, done. Very good. Very good. Ritik, will you listen to me? You want to learn units and dimensions properly and it's very confusing? You know what to do? Come on, my warriors. What should you do? Very easy. There is my playlist. Where is the playlist? It's there on this channel. Go to the physics section, go to the playlist, units and dimensions. Watch it right from the scratch. Do not skip anything. And trust me, sit with a pen and paper and try to solve as I solve. That's it. After that, read your book and then see whether you understand or not. Okay, just try and do this. Okay, just try this. Okay, so the answer is option C, correct. Done, done, done. Correct, Roshni. Watch Capto's lectures. Very true. Like you're watching right now. A particle of mass m is projected with certain velocity from some ground with some speed with an angle 45 degrees. What is the angular momentum of the particle about the point of projection where the particle is at the maximum height? Interesting. Interesting question. Let's see. Projectile motion combined with angular momentum. Very fascinating. You have to find the angular momentum about the point of projection, matlab this point, but the particle is over here at the highest point. Remind me, if you remember correctly from projectile motion, what is the velocity at the highest point if initial velocity is v? Do you remember? Only x component stays. Only x component stays. So what's the x component? V cos theta. Theta is 45. So obviously it is v cos 45. Cos 45 is 1 by root 2. So this is v by root 2. Isn't that correct? Yep, it is v cos 45. Great. About this point, that means I will draw the vector r. So let me show the vector r in blue. I love colors. Look at this fascinating colorful diagram. This is r vector. Now I'll be like, sir, what is the angle between r and velocity? Because for angular momentum calculations, I need m r v sine theta. This theta is the angle between r vector and the velocity vector. So I need that angle. Now that angle is not 45. Yes, it's not 45. You have to do some lot of circles to find that out. But I'll tell you something. I gave you an alternate definition just some time back, and I told you you can use m r perpendicular into v. Do you remember that definition? So all you need to do is drop a perpendicular on that velocity. So just extend that line of velocity. So this is the line of velocity. It gets extended like this. Just drop a perpendicular. How does the perpendicular look like? This is the perpendicular. Wow, this is r perpendicular. Interesting. And I think I know what is r perpendicular. It's same as this, which is the maximum height. That's it. So this problem now has converted into, by the way, this was velocity. So this problem now got converted into, remember this perpendicular is same as the maximum height, h into the velocity, which is v by root 2 at that point. Isn't it crazy? So cool now. No, it's not 1 for 35 degrees reduction. It is not. Now you just solve the problem. Height formula. What's the height formula? V square sine square theta by 2g. That's the formula. So V is V square sine square 45 divided by 2g into V divided by root 2. Interesting. M into V square into V will be M V cube. I think V cube is there everywhere, most of the places. Okay, great. Sine, and there is G over here. Sine 45 is 1 by root 2. Square of that is 1 by 2. So you get 2 from that. This 2 as it is, and this root 2 as it is. So this will become M V cube by G. 2 2s are 4. 4 root 2. Oh, 4 root 2 is not there. Anyways, this option and this option is not true, because there is no V cube over here. One of them should be correct. Root 32. What is root 32? Root 32 is 4 root 2. Yes. So this should be 4 root 2, which is root 32, one and the same thing. So option B is correct. Done, done, done. Isn't it clear? What an amazing question. Projectile motion combined with angular momentum. And you now know how to find angular momentum of particles. Beat any situation. And the beauty of this problem is I did not go by the original definition. I went with the modified definition, which is mr perpendicular into V. Sometimes you might have to use mr V perpendicular, sometimes mr perpendicular V. So it depends from situation to situation. Okay, so that's option B. Now let's move to angular momentum of rigid bodies. So each particle has angular momentum. Any particle which moves about some point has angular momentum. If you have a body, you have a rock, you are rotating, you are in a merry-go-round, you are seeing a rotating propeller, fan, anything. Each particle on that is rotating, it has angular momentum, so the body as a whole has angular momentum. So, to find the angular momentum of a body, the angular momentum of a body is nothing but the sum of all angular momentums or angular momentum of the particles, of all the particles. It's basically m1 r1 v1 plus m2 r2 v2, like that till mn rn vn. All these velocities are perpendicular velocities or tangential velocities. mrv sine 90, all the velocities are perpendicular, because we know that if you have r, these velocities are always perpendicular, okay, whenever you start from the axis, correct? So what will you get? m1 r1. Oh, I know one more thing. Each velocity is omega into r. Omega into r. R decides velocity, so it is nothing but omega into r, and similarly omega into r2, and so on and so forth. Last term mn rn, omega into rn. Interesting thing is omega is same everywhere, so just take out omega. Here you have m1 r1 into r1, which is m1 r1 square. Similarly, you will get towards the end, omega is outside, mn is here, rn into rn is rn square. Now I think I know what this is. I have defined this already in the first lecture, which is nothing but moment of inertia. So I think I got what I wanted. Angular momentum of a rotating body is omega I, or I omega. You'll be like, sir, it's difficult to remember this. Wait a minute. Remember what was momentum? Momentum was mass into velocity. Equivalent of momentum, angular momentum. Equivalent of mass, moment of inertia. Equivalent of velocity, what is it? Angular velocity. That's it. Simple. This is the trick to remember it. So you don't have to remember separate formula. Momentum is mass into velocity. Angular momentum is angular mass. Moment of inertia into angular velocity. Done, done, done. That's it. Simple. Great. So this is the angular momentum of a body which is rotating about an axis, purely rotating about an axis. Very, very important. This is pure rotation only. So that's why I started my lecture with axis of pure rotation. Look at this. This is for purely, okay, purely rotating bodies. And this is your instantaneous axis of pure rotation. It's your instantaneous axis of pure rotation. That's why moment of inertia about axis of rotation, angular momentum of that axis, and so on and so forth. But sometimes, you know, bodies may not just be rotating, it will be translating plus rotating. So what will you do in that case? Like, sir, I know this, I have attended your class from the start. If a body is translating and rotating, I will convert it into a pure rotational problem. Very good, proud of you. So if a body is translating plus rotating, you will reduce it to just pure rotation, and then you will try to find using this formula. But wait a minute, what if I tell you that you can avoid this certain times? Because every time it might not be easy or it might not be efficient to go via this way. Every time finding via axis of pure rotation. Sometimes it's very easy to go via this way. Sometimes it's difficult or lengthy. So that time use my second method. Everybody excited to see the second method? Okay, the second important formula. Oops. Yeah. So what is the second method to find the angular momentum? Okay. So angular momentum of a body which is translating and rotating. Glad to know that, Rock John, Sasi Vadan. Thank you so much. Glad at least you see my recordings. Very good. I know a lot of people do not come live. Some of you watch it as a recording because of some other commitments or clashes. So when you have a rotating plus translating body, that's when you need the knowledge of center of mass. You should know where the center of mass is and what is the velocity of the center of mass. You should know from the point where you want to find the angular momentum, you should know the distance. So this is the position vector of the center of mass. So what is this? This is the position vector of the center of mass. Now the total angular momentum is the sum of two terms. What are the two terms? Assume that this is a condensed particle, just one particle. What is the mass? M. One particle going with this velocity. What is the angular momentum? We all know if there is a mass moving with certain velocity, this is the distance. What's the angular momentum? M, which is the mass of the body, R, which is RCM cross velocity. In this case, it's velocity of the center of mass. That's the first term. Cool? That's the first term. The second term is, this entire thing was assumed like a point. But I know it's not a point. There are some dimensions, there is some mass distributed around it, and that is rotating. Now, imagine it to be rotating about the center. So what is the angular momentum of a body which is just rotating about an axis? I know it is I into omega, mass into velocity, and moment of inertia into angular velocity. So that's it. Just add that other term, which is moment of inertia about center of mass into omega. That's it. That's the complete answer. So it's a sum of two terms. The first term is usually referred to as angular momentum of center of mass, because you are condensing it to be a particle, and this is angular momentum of spin with respect to center of mass. So you sit on the center of mass, you see the spin, and that's the spin angular momentum. So this is the formula. Let's solve questions, you will get a hang of it. Great, cool. Let's get going to some amazing questions on the final part of finding angular momentum. My God, I just realized taking two classes together puts a lot of pressure on my throat. Okay. Let's get going. Okay, I have put this slide for you. You will again get it in the PDF like you always know. Whatever I write, most of the things I'll put it on the slides for your convenience. So let's solve this question. You have a rod which rotates about a vertical axis. Wow. So there's a rod, there's a vertical axis, and this rod is rotating like that. Okay, this rod is rotating like that. So the question is, what's the angular momentum? First thing you tell me, is the rod rotating, or is it translating, or is it rotating plus translating? And if it is rotating, what's the axis of pure rotation? Is it rotating purely? Is it rotating plus translating? What do you see? I think that will solve the half of the problem. Jai Tirtha has already given the answer or something. Okay, let's figure this out. I don't know whether it is correct or wrong. I feel all the particles are rotating about this axis. So obviously, what is this? This is the instantaneous axis of pure rotation. Correct? Very good. Now, once I know it is purely rotating, I know which formula to use. The angular momentum about that axis is moment of inertia about axis of pure rotation into omega. But I think I need the moment of inertia of the rod about this point, and I do not know the moment of inertia of the rod about that point. I just know the moment of inertia about the center of mass. And what is the moment of inertia about the center of mass? It is ml square by 12. So I need to shift it, and then I get it about the end and use parallel axis theorem. Yes, parallel axis theorem. That's why I taught that to you in the first class. So it's moment of inertia about center of mass, which is ml square by 12 plus ml by 2 square. So that's your moment of inertia into omega. You can do the math. It will just come out to be ml square by 3 into omega. So is ml square by 3 there? Yes. Many people are going to mark this. Please do not do this. This is not the correct answer. You have to shift the moment of inertia. I hope, Jayatirtha, you understood. And it is only rotating. Correcto. Answer is C, Akhil. Very good, Dakshin. Very good, Suchi. Very good, Santosh. I hope, Jayatirtha, you understood it. Yeah, and Murdhwaj also. Okay, chalo. Moving on to the next question. Wow, we have 4 questions over here. These are not options. Okay, these are not options, my warriors. Find the angular momentum of a disk about each axis for all the 4 situations over here. This will clear all your doubts. Trust me on this. Okay, let's go ahead. Let's start with the first one. Okay, let's start with the first one. In the first situation, option A, or rather question A, this is just a disk is rotating. So this is just pure rotation. So for pure rotation, the angular momentum, okay, for situation A, I'll just put LA, will be moment of inertia about that instantaneous axis of rotation into omega. So what is the moment of inertia about this axis for a disk? It's mr square by 2, right? So mr square by 2 into omega. So that's angular momentum. Okay, done with option A, or rather question A. Cool. Let's go to option B. Wait a minute, what do we have here? The axis is somewhere outside. The disk is rotating about an axis outside of its mass. Okay, I know what to do. I need to shift it. So again, this is the instantaneous axis of rotation. It's rotating about that axis. So I think we need to shift the moment of inertia first before solving the problem. So the angular momentum in the B case will be moment of inertia about center of mass plus m into shift square into omega, because I need moment of inertia about this axis. So moment of inertia about center of mass is mr square by 2 and shift is d, so md square by 2, the whole thing into omega. So you want to solve it further and take m by 2 outside, so m omega by 2 r square plus d square. That's the angular momentum about point B, the B problem. Clear? Very good. Now C and D are tricky, so let's solve it properly. You have a disk and it is rotating like this and the center is translating. So I think I know what to do first. I'll just write down the main theorem or the main formula. So the angular momentum for translation plus rotation is a sum of 2 things: m RCM, position vector of the center of mass, into VCM, plus moment of inertia about center of mass. It's moment of inertia about center of mass into angular velocity. So it's a sum of two terms. Remember, this is the formula I need to use for C as well as D. Okay, let's see how to do this. First, omega is this way, right? Velocity is like that. So think center of mass is here. Position vector will be here. But velocity is here, position vector is here. I do not like that. You know what we can do? We can take the perpendicular. Remember, when R and V are at an angle, either you split velocity or you split R. I feel it's better to split R in this case. Look at that, because this is your RCM. This is your RCM perpendicular. And how much it is? It is nothing but D itself. Can you see that? This is D. So the first term in this case, angular momentum, in the case of C, will be M R perpendicular, which is D, into VCM. VCM is V. But what is the direction? What is the direction? No, it's not D square. It's just D. Be careful, Roshni. That second term will come later on. Okay, I think. Oh, sorry. For B, yes. I'm so sorry. Why did I put D by 2? I'm so sorry. My bad. Thank you for pointing it out. This was not supposed to be by 2. Yep. So let me just remove this by 2 and remove this by 2. Thank you so much for pointing it out. It was just MD square. There was no need of 2. Correct. My bad. So this was just by 2 over here, nothing else over here. Yep. Thank you. Thank you for letting me know. Cool. Yeah, this was just D. There was no D by 2. Cool. Now, going back to this problem. What do we have over here? Yes, R cross V. R is there, V is here. R is there, V is here. R is here, V is here. Do R cross V. See where it goes. R cross V. It goes inside. And what is inside? Negative Z axis. So minus. So it is basically minus K cap. See if this makes sense. Why is this minus K cap? Okay. R is here, V is there. When you do R cross V, it goes inside. That is the first term. Second term, be careful now. Okay, what is the second term? I omega, moment of inertia into omega. It's nothing but M R square. It's a disk by 2. So that's why by 2 into omega. How is the angular velocity? It is clockwise. So curl your fingers clockwise. See where the thumb goes. It again goes inside. So again it's minus K cap. So this is the angular momentum vector for the option C or question C. Is that clear? Is that clear, my warriors? So this is very tricky. So that's why I said you should learn how to use this formula. So we are going to see these questions C and D very carefully, because that will alone teach you how to use this formula. Now let's go to the D option. Trust me, D is even more trickier. Yes, I'll tell you how. Okay, so let's just split this. I don't need this now. Let's look at D. It looks similar, but there is a catch. Look at the axis. The axis is vertical. Yes, the axis is vertical. The first part is same as over here. You can see that. So again, you can see this is your RCM vector. This is the center of mass. This is your RCM perpendicular, which is D itself. So the first term, which is the angular momentum for D object, will be M. R perpendicular is D. V is V. And again, same logic, it is minus K cap. So I'll just put a minus sign and K cap. That's same like before. Omega is like that. Be careful. So for the second term, when you write M, oh, wait a minute, you need to find the moment of inertia about the diameter. What's the moment of inertia about a diameter for a disk? You need to figure that out by perpendicular axis theorem. Yes. Remember, the moment of inertia about the diameter is same whether you take this axis or whether you take this diameter. And about the central axis, when you rotate it like that, okay, I know that the addition of these two, ID plus ID, remember perpendicular axis theorem, if you add both the perpendicular axis moment of inertia, you get the moment of inertia about the perpendicular axis to the plane. So that will be mr square by 2. So 2ID is mr square by 2. So therefore ID will be mr square by 4. Getting it? Wow, beautiful. Most of you have put it up before I solve. Perfecto. So that means over here I should add mr square by 4 into omega, but it is vertical axis. Look at that. If you curl your fingers this way, it goes in the y-axis. Y-axis is nothing but j cap, and that is plus. So this is the angular momentum for this question D. What a beautiful question. I'm pretty sure you enjoyed this. Lovely. Enjoyed this. Actually, I was born in Tamil Nadu. Yep, I was born in Salem. Yes, Salem, Tamil Nadu. That's where I was born. Again, kariye Divya. Divya, here is what I will tell you. Please watch it as a replay, but I'll tell you the gist of this. When you look at this body or this body, it's translating plus rotating. So split it into two categories. So the first part, look at the center and see that it is translating. Here also, it's translating and then rotating. So for translating, use this form, MRV, MRVCM. R is this, but I don't want to find the angle between them, so I drop the perpendicular. Remember the definition, MR perpendicular into V. So the perpendicular drawn will be this distance D. So that's why MD into V. That's the first term. And why is it negative? Because if you do R cross V, it goes inside, which is negative Z. So that's why minus sign. The second term is this one. So it is spinning about the diameter. Yeah. So it's spinning about the diameter. So about the diameter, the moment of inertia is not mr square by 2. So for that I use perpendicular axis theorem, which I taught you in the first class. So what is that replay? I know about the diameter, whether I rotate it like this or like this, it's the same thing. And the addition of these two will give me the moment of inertia about this axis, which I already know is mr square by 2. From this I got that moment of inertia, which I have used over here, and that into omega will give me the angular momentum, but that is about j cap or y-axis because it is rotating like that. I hope that makes sense. Is it clear? Yep. Okay, so that's the summary or the gist of this question. So what have you learned today? You have learned the art of calculating instantaneous axis of pure rotation, their concepts, how it's calculated. You also know how to calculate angular momentum of a point particle, rotating body, and rotating plus translating body. You will need this in the next class and the next to next class when we will be doing conservation of angular momentum principle. Trust me on that. So this is your first homework question. Put the answers in the comment section below. This is, oops, this was not supposed to be shown. The second homework question, this was not supposed to be shown. Ignore. And yep. And this is this has to be put in the comment section below. And let me show you last time who and all have solved the questions out here. So where were we? Yep, is that me over here? Yes, this is the video. Yes, very good Ishpreet, congratulations. Very good Swarlina, very good Roshni. And Roshni, thank you for that lovely heart and comment. And Harita, very good. Chandan, very good. So Suchi, I have watched the replay, and on that day there was sudden power cut, no problem. So you will solve the questions after today's session as a replay, no problem. So I think Swarlin also missed it. I think last time I conducted the class in the evening at 5:30. That's why many of you missed it. Okay, Saja, very good. Very good, Yash. Thank you, Abhirami. Welcome. And XX Mars. No problem, Aishwarya. I'm guessing you caught up. Gokulnath, I hope you have also caught up. How to see my derivation courses? So Dakshin, go to enroll more Okay, in your dashboard of Vedantu, go to enroll more courses, and over there just type derivation of, let's say, center of mass or something like that. Okay, so derivation course for 11th standard, just search for that, you will get it. If you're, oh, my batch for 2023 Abhirami is not there. I'm not teaching in a long-term batch, but you will see my micro courses Abhirami. So that's something which you should look forward to. Yash found third question tricky. Good, but still you attempted it. That's the important part. Now, also let me tell you, even in today's lectures, description box, if you want my derivation courses, etc., all you need to do is click on this link, which is JEE 2 years, and that will open up the page for your 11th revision, 11th crash courses, 11th micro courses, 12th standard courses which are going to start. So do not miss this chance for joining the batches early. Even if you have backlogs, those will be cleared, because we have personal mentorship also, we have doubt clearing on the mobile app also. You can watch the recorded classes as well. You can also give test series, see where you stand. Sometimes when you give tests, that's when you understand where your mistakes are. Not just that, you get assignments as well as class notes, lots of study material available for you to practice, along with the Tattva material, which is the Vedantu material, which will be given to you. If you want, you can try it out for 15 days also for 750 rupees. It's very less. So just try it out for 15 days. But if you feel that you're satisfied, sir, I want to go for the entire year, go ahead, click the buy complete course option. There is EMI option also available. Do not forget to use my coupon code SHHPRO, because only then, if any problem happens during enrollment, etc., you can directly get in touch with me and I can, sort the problems really quick. All right. So that's something which you should look forward to. I'm so glad you were there till the end. Okay. Zara. Wow, what a name. That reminds me of that song. Okay, so welcome Zara, and I hope you hit the subscribe button, because then next class you can watch us live right from the beginning. Welcome to the Nurture series. And my next live class, Sushruta, will be, today is Wednesday, so Friday, I guess. Yes, Friday my next class will be doing rolling and slipping. Beautiful session on rolling and slipping. Take care, Srashti. Bye bye Roshni. Bye bye Sushruta. Bye bye Devya. Bye bye Dakshin. Take care, my warriors. Have a great time and eat your dinner properly, and stay fit, stay healthy, keep solving more problems, and do not give up, okay? Because warriors never give up. Take care, my warriors. Have fun. Hasta la vista. This was Shreyas here.